Hello guys, welcome to a new video, and in this video we will be solving LeetCode problem 1752, which is check if array is sorted and rotated. So let's get started. So the problem statement says that we are given an array nums. Now we have to return true if the array was originally sorted in non-decreasing order, then rotated some number of positions including 0, otherwise we have to return false. It is also given that the array may contain duplicates. That is, there may be duplicate entries in the array. So the problem statement is pretty straightforward, kind of. It says that we'll be given an array and we have to check if the array was originally in ascending order, and after that if it was rotated by certain positions or not. So let me just give a brief about what a rotation in an array means. Suppose I have a array like 2, 4, 6, 8, 9, and if I do a rotation in it, then the last element, if I do one rotation, then the element on the extreme right will shift to the zeroth index, and entire array will shift to the right by 1. So let's take one example and see. Suppose there's an array 1, 2, 3, 4, 5, 6, 7. So if I do one rotation in it, then the array will be 7, 1, 2, 3, 4, 5, 6. If I do another rotation, which will be my second rotation, the array will be 6, 7, 1, 2, 3, 4, 5. So we can see that in each rotation, the entire array elements is shifting by one place towards the right. So that's how rotation in array works. So we have to now check if the array was originally sorted in non-decreasing order, that is in ascending order, and then rotated by some number of positions. Okay, so before jumping into the logics, let's have some observation on rotated and sorted arrays. So if I consider an array which is like if I consider a sequence of numbers which are arranged in ascending order, let it be like 2, 8, 12, 32. I'm taking random numbers, 68. So one thing that I can observe is that as I go from left to right, that is from 0th index to the n minus 1th index, the value, the magnitude of the numbers increases. Like the magnitude of number increases. Like if I'm starting with 2, then the next number is 4. It's increasing. Then again from 4, the next number is 8. It's again increasing. The next number after 8 is 12, which is again increasing. 32, again increasing. Then after 32 I'm getting 68. It's again increasing. That means as I'm moving from 0th index to n minus 1, where n is the total number of elements in the array, when I'm going from 0 to n minus 1, this line is increasing. I'm not getting a drop in the line. Let's rotate an array which was originally sorted and see what observations we can make from it. So in this, the line was originally increasing, right? Line was increasing. Now if I apply one rotation, then 68 will go here, 2 will come here, 4, 8, 12, 32. Now let me apply another rotation, which will be my second rotation. It was the first rotation. It was the first rotation. It is my second rotation. After second rotation, my array will be 32, 68, 2, 4, 8, 12. Okay. See, in this array, as I go from 0th index to n minus 1. Now this is my index 0, this is index 1, index 2, index 3, index 4, and index 5. Okay, it is n minus 1, index 5. Okay, so as I go from 0 to n minus 1 index, the sequence first increases. From 32, it increases to 64. But from 64, it's decreasing. Again, from 2, it's increasing to 4. Then from 4, it's increasing to 8. And 8, it's increasing to 12. So the important observation to be made here is when there is a rotation in the array, I'm getting a drop. I'm getting a drop in the line. Now, this it's pretty obvious that this part, this part was supposed to be after 12. This part was supposed to be after 12, and since originally the entire array was sorted, so 12 will be greater than 12 will be lesser than 32. Like these two values will definitely be greater than the current last element, which is 12. These two elements, these mark them, these two elements will be greater than the last element, because they were supposed to be present after this. They were supposed to be present in these positions. Okay, but due to rotation, they came in front. So one thing is clear: whenever I am getting a rotation, then I am getting drop in the values. I'm getting a drop in the values. In the values. Now, one thing is that there can also be a situation that there may not be drops. There may not be drops, and that situation will arise only if the array is rotated that many number of times, after which the array again becomes sorted. That is, the array is rotated the number of times which is equal to n, that is the length of the array. If let me just have an example. Suppose I have an array 1 2 3 4. After first rotation, the array will be 4 1 2 3. After second rotation, it's 3 4 1 2. After third rotation, it's 2 3 4 1. And after fourth rotation, the array is again 1 2 3 4. It's same as the first starting array that I took. Both are same. That means if the number of rotation is equals to n, then I'm getting the same array, and in this case I will not get a drop. So from the discussions, what observation can I make? If there was a rotation in the sorted array, if there was a rotation in the sorted array, then there can be a drop. Now I've used the word can because of that one edge case in which if the array is rotated that many number of times as many the number of elements are present. In this case, I will not get a drop. Other than this case, I will get a drop. At least one drop I will get. Okay. So I'll get one drop in every other case if the array is rotated any number of times the other than the value of n. Basically, if my array changes, if I don't get the same array after rotation, and if I do the rotation in such a way, then I will definitely get a drop. Now the question is, how many drops can I get? If my array originally before rotation was sorted, how many drops can I get? So the answer is 1. I'll not get more than 1 drop. Okay, so let's have an example and see. Suppose this was my original array. This one is my original array 1 2 3 4 5 6, which is originally in ascending order. Now I rotated this and I got this array. This is my rotated array. Now here it was originally increasing, and here this part is increasing and this part is also increasing, and here is a drop. So what happens when we rotate an array which was originally in ascending order? If an array was originally in ascending order and I still rotate it, then what happens is the entire array gets split into two parts, two separate parts, each of which part is in itself in ascending order. If I look into this part and if I look into this part, they are individually in ascending order. They are individually in ascending order. It is also individually in ascending order. But in the original array, this part was supposed to be after this, right? This part was supposed to be after this, and these elements were supposed to be greater than this. That's why I'm getting a drop here. I'm getting a drop in this region because these elements were supposed to be after it, and it due to rotation they are placed before 1 2 and 3. So the thing is, if my array was originally sorted and after that I rotated it, Then after rotation, the entire array will be split into two parts. I cannot have more than two parts where each individual part will be sorted up in ascending order. I will have exactly two parts and one point where I'll get the drop. Let me repeat that again. If an array was sorted originally in ascending order and I applied some rotations in that array, then after rotation, I will get exactly two separate parts of the array. I'll get exactly two separate parts, each of which is individually sorted. Here we are getting these two parts, this part and this part. And these two parts are sorted. I will never get more than two such parts. If I get more than two such parts, that means my original array was not sorted in ascending order. If my original array was sorted in ascending order, then I will definitely get only two parts. And for only two parts, I'll have only one drop. I'll have only exactly one dropping point. Now let's take an example for the other case. Okay, so let's look at this example. If this was my original array, if this was my original array, 1, 2, 3, 7, 4, 8, 9, 8, 9, 5, 6. It is not originally in sorted order because 7 is after 4 is after 7, means 4 is in between 7 and 8. So it's not in ascending or it's not in ascending or descending order. So now after rotation, I am getting 5, 6, 1, 2, 3, 7, 4, 8, 9. See, originally the values were like it was increasing, then suddenly decreasing, and again increasing, again decreasing, again increasing. And here after rotation, this part. So after rotation, I'm getting, yeah. So after rotation, this is like 5 to 6, it's increasing. Then again from 6 to 1, there is a drop. Then from 1 to 2, it's increasing. 2 to 3, it's increasing. 3 to 7, it's increasing. 7 to 4, there is a drop. And 4 to 9, 4 to 8, 8 to 9, there is again it's increasing. So I am getting two drops here. Now this two drops signifies that my original array was not sorted in ascending order, because if my array would have been in sorted order, then there would have been exactly one drop, because in a sorted array it would have looked something like this, like 1, 2, 3, 4, 5, 6. My values would have been like this. Suppose I'm rotating by 3 positions, then it would have been 4, 5, 6, 1, 2, 3. That means I'm splitting it at this point. So this part is also sorted, and this part is also sorted in increasing order, and I'm moving this part to here. That means I'm bringing this line over here and this line over here. So I'll get exactly one drop. Because this line was supposed to be in front of this line. So by now it's clear that if my array was originally sorted and then rotated, then I can get at max one drop. I can also get zero drops given the case that the number of rotations is equal to n, where n is the length of my array. So I'll get exactly one drop. Not exactly, at max one drop. Sorry, I can get at max one drop and not more than that. So from the given array, what if I just I iterate through all the arrays, all the elements of the array, and I just count the number of drops present and check if the number of drops goes beyond one, then I'll just return false. And if the number of drops is less than or equals to one, then I can uh, I can return true, saying that yeah, the array was originally sorted and then probably rotated by some index, by some position. Okay, so let's have a dry run of the logic that we have just developed. So at first I'm having my I at index number 0. So I'll have a count. I'll have a variable count equals to 0. So this will basically count my, this will count my number of drops. So my number of drops. This will count my number of drops that appears as I go from 0th index to n minus 1th index. So standing at index 0, I'll be checking if the element at index 0 norms at index 0, or let's say I, because I'm denoting it with I. So if nums at I is greater than nums at, nums at I plus 1. If yes, then I'll just do a count plus plus. If no, then I'll just continue the iteration. I'll go to the next step again. Okay, so let's quickly write down the pseudo code for this. Okay, so I'll have my array as nums. It will be of length n. Okay, so initially I'll have a variable count equals to 0. Now start a for loop. Start with I equals to 0, and my I will go till n minus 1, and yeah, plus plus. Okay, now one thing is that I have to check if in which index I'm standing. If I'm standing on my last index, then in the last index, I'll be checking if the last index is less than my 0th index or not. If okay, like for now, let's just write up the pseudocode, and we'll try run it once, and then we'll have another explanation on why I'm checking this part separately. Okay. Five, 6, 1, 3. Okay, so when I'm standing at index from 0 to n minus 1, and I'll be checking under this section. So I'll check if element at the current index is greater, if the element at the current index is greater than the next index. If it is greater, if the current index element is greater than the next index element, then there is a drop. Again, when I'm standing at say index number 2, I'll check if the array, if the value at index number 2 is greater than value at index number 3. If yes, then again I'm getting a drop. When I'm standing in the last index, then I'll check if my last index is greater than my index at 0. If the element in my last index is greater than my element in the 0th index. If it is so, I'll do a count plus plus. Now see, if the array was originally rotated, or if the array was originally sorted and then rotated, then the last index element will definitely be smaller than the element at 0th index. See, uh, it was originally 1, 2, 3, 4, 5, 6. After rotation, it became this one. So my point of rotation is this one, and this entire part was supposed to be after 3. So 3 is, this part was supposed to be after 3. So 3 will be definitely lesser than 4. And if in the special case of rotation, such that in the special case of rotation where the array gets back to its normal order like 1, 2, 3, 4, 5, 4, 5, 6. In this case, only in this case, the last index element will be greater than the first index element. Well, in this case, I'll not get a drop anywhere in between. If the original array was sorted and rotated like this, then I'll not get a drop anywhere in between, but I'll get a drop here. So this drop will get me a count of 1. Like it means this drop will increase the value of count as 1. And so finally after that I'll be checking if my value of count is greater than 1, then I will just return false, else I'll just return true. Okay, so let's code this solution now. I'll have a variable as drop count equals to 0. Then I'll just run a for loop for int I equals to 0, I less than counts dot length I plus plus. Okay, so now I'll do the checks. If first I'll check if I'm standing in my last index or anywhere in between. If my index is equals to nums dot length minus 1, in that case I'll just check if my current index, if the value at the last index is smaller than the, if it is greater than the index element of zeroth index, because if it is greater, then I'll consider it as a drop, and this drop would only come if the array is rotated such that the array after rotation the array gets back to its normal position. So okay, so now I'll check if my drop count is greater than 1. I'll simply return false. Otherwise, I'll return true. So let's run it. Okay, this is a fast. Now let's submit. Okay, so fine. Now let's discuss about the time and space complexity ones. Okay, so talking about the time and space complexities, since I'm not using any extra space here, the space complexity will be big of 1. I'm using a constant space. And talking about the time complexity, what I did is I just iterated through the entire array. I just iterated through the entire array using a for loop once. So my time complexity will be big O of n. Thank you so much guys for watching the video till the end. You can drop your experience in the comment section, and if you feel that I could have explained you the solution, then do consider giving a like and subscribing to the channel.